Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 19, Understanding Variability when Estimating a Population Proportion. Classwork. In a previous lesson, you selected several random samples from a population. You recorded values of a numerical variable. You then calculated the mean for each sample, saw that there was a variability in the sample means, and created a distribution of sample means to better see the sampling variability. You then considered larger samples and saw that the variability in the distribution decreased when the sample size increased. In this lesson, you will use a similar process to investigate variability in sample proportions. So here's example 1, sample proportion. Your teacher will give your group a bag that contains colored cubes, some of which are red. With your classmates, you are going to build a distribution of sample proportions. Each person in your group should randomly select a sample of 10 cubes from the bag. Record the data for your sample in the table below. Okay, so situations like this are difficult to do in a video when you're not in a classroom setting. So let's just pretend I gave you a bag that contains colored cubes, and I know the number that are in the bag, but you don't. And you are going to build a distribution of samples. So each person in your group should randomly select 10 cubes, record the data for your sample in the table below. So I'm going to use a website, and it's called Random Selection. So over here, here's the result right here, red. So it's decode.fr/random selection to give them credit. So the first drawing was red. So I set it up so there's different colors in the bag, red, blue, green, and yellow. And the first drawing was red. So I'm going to put that in, and I will just do that here. Okay, then I'll go back to here, and I will randomly select, and the result was red again. So I write in red. And I'm going to keep doing this until I do it 10 times. Blue this time. Red again. Green. Blue. Yellow. Green. Yellow. And yellow again. Okay. What is the proportion of red cubes in your sample of 10? And there's 1, 2, 3, out of 10. Okay, so red, red, red. The rest are yellow, yellow, green, yellow, blue, green, blue. So it's 3 out of 10. So this value is called the sample proportion. The sample proportion is found by dividing the number of successes, in this example the number of red cubes, by the total number of observations in the sample. Part C says write your sample proportion on a sticky note and place it on the number line that your teacher has drawn on the board. Place your note above the value of the number line that corresponds to your sample proportion. The graph of all students' sample proportions is called a sampling distribution of the sample proportion. Okay, so again, since we're in a classroom setting, what I did was I drew the number line from 0 to 1, 1 being 100%, and if this was a class setting, let's just pretend there's 10 students in our class, and I'm going to use a calculator to do a random number generator to generate their outcomes. It's not as accurate as really doing it, but it suffice for this example. So in order to do that, I hit math, arrow over to probability, and 5 for random integer. So I'm going to tell my calculator that I want to choose random integers between 0 and 10, and I'll just move the decimal place because this is integer and these are not integers, they are rational numbers. So I'm going to say from 0 to 10. And I hit enter, and I got 10, which is a 1. So then I would put a dot right here. And I got 0.3, which is 3/10. So there's my choice, or there's my selection from this sample right here. So 3/10 is 0.3, so there's mine, and there's the next one, and I'll do this 10 times so that we have 10 dots on our. So hit enter again, and it's 9, which is 0.9. And hit enter again, 1, which is 0.1, and then 5, which is 0.5. I'll do 2 at a time. So here's 0.1, and here's 0.5, and hit enter, and I got a 0.4 and a 0.8. So that's 3, 6, 7. I have to do it 3 more times. So 1, 0, 2, 3, and 1. So 0, 0.3, and 1. So there is a sample of 10. So describe the shape of this distribution. Actually, there's really not much shape to it. It's spread out. Describe the variability in this proportion, in the sample proportions. The variability here is large. So what I'm going to do is I'm going to make the class size larger to see what happens. Let's make it 20 and do this 10 more times. So here's a 2, an 8, and a 10. Two, 4, 0. 10, 1, 0. 6, 9, 10. Okay, so this is still spread out. It's not going in the way that I would suggest it would go because of the calculator choosing random. It's giving the possibilities of these outcomes equal value, and that's not what would happen in this situation. And the reason I'm saying this is because I know what was in the bag, and so that's not working. So I'm going to bring in a sample of what it would probably look like if this was done in a class setting, but I was just showing you what we would do in a classroom if everybody went up and put their results on the board. Here's what they would get. Okay, this would be more of what would appear to be if you did it in class. And I'm saying this because I know what was in the bag, and when I set up this website that we used to do the drawings, I knew that here's what I put in. It was a multiple of, or a tenth of what they said, but there was supposed to be 40% red, so I put 4 red and 6 that were different colors. So red would have a bigger probability of occurring, and it should have been around 40%. Okay, so in this case, if it came out like so, we should have values that were centered around the actual. And this is a bell-shaped curve, so the shape of the distribution is symmetrical distribution clustered around 0.4. Okay, describe the variability. So you would say the spread is from 0.1 to 0.7 with most of the data between 0.3 and 0.5. Okay. Based on the distribution, answer the following. What did you think is the population proportion? So looking at this, if you took an average, you would think the population proportion would be 0.3 or 0.4 because it's centered around there. Okay, so let me recap this page before we move on. So this was a sample proportion that I brought in. It's centered around 0.4 or maybe 0.3, somewhere in that area. And it's symmetric. This is a bell-shaped curve. Describe the variability in the sample proportions. The spread went from 0.1 to 0.7, with most of the data between 0.3 and 0.4. What do you think the population proportion is? Well, that's where it's centered around most of the data, so it would be, again, 0.3 or 0.4. How confident are you in your estimate? I would say not very confident because the variability is large, going from 0.1 to 0.7. Okay, now moving on to this problem. What do you think would happen to the sampling distribution if everyone in class took a random sample of 30 cubes from the bag? To help answer this question, you'll repeat the random sampling you did in part A. Draw 30 times. So I'm going to do that on this website now. So now we're going to look here, and I'm going to do 5 at a time and do that 6 times to get a total of 30. So, random select. Green. Yellow. Green. Yellow. Red. So it was green, yellow, green, yellow, red. And I'll put a check by the reds because that's success. Yellow. Green. Red. Yellow. Red. So we had 2 more reds. Da-dee-da. Green. Yellow. 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 Green. Five more times. Blue. Red. Green. Red. Red. Okay, so hopefully we don't get blocked here because he said I'm using this a lot. He must have a problem with that. Blue. Blue. Green. Red. Blue, blue, green, red, and blue. Blue, blue, green, red, blue. Okay, 5 more times and we're done with our sample. Red. Blue. Green. Green. Red. So it was red, blue, green, green, red. So I have 3, 4, 5, 6, 7, 8, 9. What was the proportion? 9 to 30, which reduces to 3/10 or 0.3. But it just said what is the proportion. So that's that. All right, write your sample proportion on a sticky note. Place a note in the number line that your teacher has drawn on the board. Place your note above. All right, so here we go. Okay, so this would be a sample proportion of what a class would probably get that would be shaped like that. Obviously, I can't do it for real in the video, but this is what would start happening. And the shape of the distribution is centered around 0.4, symmetrical, and goes from 0.2 something to 0.5 something. So I'd say about approximately 0.3 to 0.5. Okay, so bringing this in, this is what it looks like. This wouldn't really happen, or this is probably what would happen if we did this in a classroom setting. This is just a sample, or an example. Describe the shape. It's centered around 0.4. It's symmetrical or mound-shaped, and it goes from about 0.3 to 0.5. And then it says describe the variability in the sample proportions. The spread is from 0.25 to 0.55 approximately. Cluster between 0.35. So if we go back and look, it is clustered from 0.35 about here to 0.45. Based on the distribution, answer the following. What do you think is the population proportion? So looking back at this, I would probably say the population proportion is somewhere in here, 0.4, 0.425. How confident are you in your estimate? I would say more confident since there is less variability. If you were taking a random sample of 30 cubes and determined the proportion that was red, do you think your sample proportion will be within 0.5 of the population proportion? And explain. Okay, answers depend on the dot plots prepared by students. So if the dot plot in example 2 part C is used as an example, okay, example 2 part C, this one, note that only about half of the dots are between 0.35 and 0.45. There are several samples that had sample proportions that were farther away from the center than 0.5, so the sample proportion might not be within that 0.05 of the population proportion. Number 3, compare the sampling distribution based on the sample size of 10 to the sample distribution based on the sample size of 30. Okay, so I brought them both in so we can look at them. This was the sample when we drew 10, and this was the sample when we drew 30. Comparing those, we would say both distributions are mound-shaped and centered around 0.4, but the variability is less in the sampling distribution of sample sizes of 30 versus the sample sizes of 10. So the data got narrowed. We're getting closer to the actual when we take larger samples. Number 4 says, as the sample size increased from 10 to 30, describe what happened to the sampling variability of the same proportion. Okay, well, the sampling variability decreased, and the sample, as the sample size increased. So the larger the sample, the closer, the narrower we're getting. 5, what do you think would happen to the sampling variability of the sample proportions if the sample size for each sample was increased to 50 instead of 30? Explain. Okay, the sampling variability in the sampling distribution for the samples of size 50 will be less than the sampling variability of the sampling distribution for the sample size of 30. Okay, that is the end of lesson 19. I apologize for some repetition. That is the end of the lesson. Review the lesson summary and go do your problem set.